Hey everyone, this is Daniel for Rock the JVM, and this video is for those of you who are aspiring Scala developers. I'm going to give you my top skills for becoming a Scala developer. So this video is for those of you who want to learn Scala as a programming language. Now, ideally, you would have some basic computer science or programming experience, ideally maybe a year of programming experience to grab Scala a little bit more quickly, but that's not a hard requirement. The topics that I'm going to talk about are discussed in great detail in my online courses at Rock the JVM, in my Scala beginners and advanced courses. And I also talk about some of these ideas in the context of libraries and bigger systems at the blog with the link in the description. Now, if you choose to learn Scala, there are some nice benefits to that. So Scala will offer you some of the best paid software engineering positions by programming language, all else being equal. This is measured by websites such as PayScale and Stack Overflow. Now, good Scala developers will think differently because the functional programming mindset will need to be internalized, and you can only obtain this mental model with lots of practice. Therefore, Scala developers tend to be quite rare, but given the enormous value of a good Scala engineer, companies are usually willing to pay top dollar for this kind of skill. Scala will also offer a very nice blend of object-oriented and functional programming with familiar syntax and concise code. Now, because of its structure and by following functional programming principles, good Scala code was often very, very short, much more than other languages, but still be fully readable and testable and maintainable and so on and so forth. Now, I sometimes joke that you can write in 10 lines of Scala what other people write in 1,000 lines of Java and so on and so forth. I sometimes joke, but it's sometimes very, very true. So Scala code can be very powerful and very short. Now, as you learn Scala, you will find it very applicable for really nice engineering problems with very high impact. Functional programming has been proven to work miracles in distributed systems, and Scala on the JVM is a very powerful combination. Now, some strong tools were written in Scala, such as Akka and Apache Spark, specifically targeting distributed systems, and these problems come with their own flavor of intellectual satisfaction, which is why we're software engineers in the first place. Now, the bonus is that once you have a taste of Scala, chances are very low that you want to go back to anything else. In my experience, teaching tens of thousands of engineers all over the world, very, 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 very low percentage of people voluntarily came back to, for example, Java after tasting Scala. I've yet to meet a handful of people that did that. Now, in this video, I want to show you the top 10 skills that you will need to be a good Scala developer, and what better way to do that than demonstrate them in my dev environment. This is the way that I like to teach, by writing some actual code and seeing it run. So this is how I'm going to show that to you. Now, Scala can have a pretty high learning curve because even to write the simplest program, you will need a lot of computer science concepts. So if I want to run my first application, I will need an object, I will need a package, and I will type in a main, which expands to this complex function signature, and then I would write a print line like hello Scala, and this will be my first program. Now, literally, every single token, literally, in this code means something. And compare that to Python, which often gets a bad rap, but if you try saying print hello Python, you will get a sense of the kind of complexity that Scala can offer, at least at the outset. Once you get a taste of Scala, you'll find that it's not rocket science. Now, first of all, the syntax of Scala is quite familiar for those of you who come from a C family of languages, such as C or Java or C# or TypeScript or JavaScript. These are all very similar, and we have these curly braces to isolate code. We have function signatures, maybe with some types in there. So the kind of approach that you will find in Scala is very similar to that of other languages. So syntactically wise, Scala is quite easy to approach. Now, in terms of mindset, you'll have to learn some skills, or rather some mental models. The first one is immutability. Because in Scala and in functional programming, we tend to think in terms of values and expressions that cannot change. So if I define, let's call this meaning of life, this is, let's say, 40 plus 2. This expression is being evaluated right here and right now, and you cannot change it. So these values cannot really be modified like regular variables in other languages, and that leads to a mental shift because, for example, if you want to repeat something, if you want to print hello Scala 10 times, normally in other languages you would think in terms of a loop like a for loop, saying for int I equals 0, I less than 10, and something like that, and do a sysout or a system out print line, let's say hello Scala. but we don't have the notion of a mutable variable here, or at least we do, but that's quite discouraged. So this kind of for loop, or this kind of repetition, is actually solved with a recursion instead. So you'll find that with immutability, you'll start to be creative really quickly. So if you want to define a loop like this, you would say def loop with an I, which is an integer starting at 0, and I would return unit in the sense that I would say print line I, and I would say if I is less than 10, I would run the loop function again with I plus 1. So notice that the kind of for loop that I used to do, now I'm doing with recursion instead. So repetition is replaced with recursion. And recursion is quite counterintuitive, especially if you haven't encountered or haven't used too many functions calling themselves over and over and over again. So this is a mental shift. This is the kind of first skill that I would recommend you take. The second is still a mindset approach, and this is the expressions versus instructions mentality. So in other languages such as Java or Python or C# or TypeScript and so on and so forth, we think in terms of instructions, like do this, do that, and then do this 10 more times while I is less than 10 and so on and so forth. Now in Scala, everything is actually an expression, which is a different form of computational structure, which is evaluated instead. So if I say eval, let's call this an if statement, and I can say if 42 is less than 100, I will return Scala. Else, I will return something not nice. Now, when I write this structure, this is not an instruction that executes step by step, but it's rather an expression. So this is evaluated to Scala. So the value of the if statement is the string Scala. It's not a function that returns Scala and so on and so forth, but this expression evaluates to Scala itself. Now, this is also a mindset shift because the expression's mentality combined with immutability, lead to different thinking patterns in terms of how we can compute something valuable. So for example, if I want to define a function that repeats a string multiple times, in regular languages such as Java or C++ or things of that nature, I would define a void or string, let's say concatenate n, and I would pass an n as an integer, so int n and string s, and this will return a string, and I would do something along the lines of string result equals the empty string, and then I would write a for loop like int I equals 0, I less than n, and I would do I plus plus, and then I would say result plus equals s, and then I would return the result. So notice this imperative approach, this instruction step-by-step approach to computing something valuable. Now in Scala, we think in terms of recursion because we also have immutability, and because we think in terms of expressions instead, we start to structure our code differently. So I would, in Scala, write an equivalent function like concatenate n, which has an n as an integer and an s as a string, and I would return a string of the form if n is less than or equal to 0, I would return the empty string. So notice that I'm returning an if expression in this case. Otherwise, I would say s plus concatenate n with n minus 1 and the same string. So notice that the approach is completely different because concatenate n is now an expression, so I can combine that with other expressions to return something meaningful. So this mental shift is necessary for us to master Scala as a mindset. The third set of skills is object-oriented programming, which I'm pretty sure you're quite familiar with if you're considering learning Scala. Object-oriented programming is a style of writing code such that we structure our code in terms of classes, instances with some sort of data and behavior, such as methods. So I would define a class, let's say person, with a name as a string and a favorite language as a string, and this would be a class with some behavior, and the name and favorite language can be fields, but here they are constructor arguments. The sort of concepts such as classes, fields, methods, constructors are also available in Scala if you're coming from a language with object-oriented support, which is most popular languages. And here we could have a method, let's say statement, make a statement, this returns a string, and I would return, let's say, hi, I'm name, and I love favorite language. So notice that I can have some methods inside. Now, the same concepts apply to Scala. So we have classes, fields, methods, constructors, also instances. We also have the concept of interfaces. In Scala, they're called traits. So I can define a trait, let's call this human, with some non-implemented fields or methods like statement, and this returns a string. And I could say the class person now extends human, so I can derive some behaviors from other data types. We also have abstract classes. Much like in other languages, we also have inheritance, as I've just described. We also have the concepts of overloading, overriding, that you can also find in languages like Java. We also have the so-called subtype polymorphism, and I'm putting this in between quotes because there are many types of polymorphism, and I can say val Daniel as human, and I'm going to say new person with the name Daniel, and obviously my favorite language is Scala. So notice that I'm defining a type on the left-hand side of the variable, and here on the right-hand side, I'm passing an actual implementation, a derived instance of human. Now, Scala came with a bunch of innovations, especially at the early phases of Scala, roughly 10 to 15 years ago, with case classes now became data classes, if I remember, in Kotlin, or records in Java, in recent versions of Java 10 years later. So case classes are lightweight data structures that will have some functionality already implemented for you so that you eliminate boilerplate. So most of the concepts in object-oriented programming you will also find in Scala with some minor syntactic differences, but I'm pretty sure that you will get the best of OOP in Scala as well. The fourth skill that I would recommend you learn is pattern matching. Literally, there's no Scala developer without it, so pattern matching is one of the most powerful features of Scala, and you can think of pattern matching like a switch on steroids, but pattern matching also has the capability of deconstructing existing instances into its constituent parts. So for example, I can define, let's say, Daniel says as Daniel match, and you can have some cases here. I'm going to say person with name and language. And I can return the string, let's say, name likes language. So notice that I'm deconstructing Daniel into its constituent parts, and I can use those constituent parts in the expression that I'm returning later. Pattern matching was also included in other languages by inspiration from Scala. Even the recent GDKs also have some primitive form of pattern matching, and they're probably going to become more advanced. And that says a lot about how useful pattern matching is. So literally, pattern matching occurs everywhere in Scala code, and I show many tricks of pattern matching in my courses and also on the blog if you want to check those out. The fifth skill, which is super important, is functional programming. And specifically in functional programming, I want you to start thinking of functions as values. So in Scala, we want to work with functions as with other values in regular code, like integers or strings. We want to pass them around, return them as results, create them on the spot, and so on and so forth. But because Scala works on top of the JVM, which was built for Java, which was not built for functional programming at the outset, Scala came with this ingenious idea to put functions as instances of particular interfaces. So if I define a function as new function1 with int and int, and these square brackets are the equivalent of generics in other languages. So in Java or TypeScript, you have the same sort of concept. And I would define a method called apply that takes an argument. I'm going to call this x, and I'm going to return, let's say, x plus 1. Now, the apply method is treated in a particular way by the Scala compiler in the sense that an instance with an apply method can be directly invoked as if it were a function. So if I define a value called 3 as a function dot apply on the argument 2, I can simply call a function on the argument 2, and that will be the same thing. So the Scala compiler came with this creative solution to make these instances invocable as if they were functions. And because they're just instances of classes, we can pass them around and create them on the spot. I can also define some syntactic sugar for that because the Scala compiler also has equivalent syntax, because this thing is very boilerplatey, as, let's say, a function version 2 as x of type int arrow x plus 1, and this is the same thing. So what I'm actually doing is I'm creating an instance of function 1 with the apply method. So thinking of functions in Scala as values, as regular values that you can pass around, return them as results, create them on the spot, this is an essential skill for functional programming. Now, after you unlock that, the sixth skill that I will recommend that you master is work functional programming on top of collections. So collections are the general things that you would expect, such as lists, arrays, maps, and so on and so forth. I'm going to give you an example. So if I define a list as list 1, 2, 3, you can process these lists as expressions. So building on top of the skills that I showed you so far by saying, let's call this incremented list as a list.map. So you would use the functional map transformation, and you would pass x arrow x plus 1, the function instance, which will then be applied to all the elements of this list, so you can return the list 2, 3, 4, for instance. Another crucial transformation is called flat map. So I'm going to call this transformed list as list.flatMap. And flat map takes a special shape of a function where for every element you'll return a mini list like x and x plus 1, and those mini lists applied to every single element of the original list will be concatenated into one. So that would be 1, 2 for the first element, 2, 3 for the second element, 3, 4 for the third element, all combined into one big list. Another important transformer is filter. Let's say even list as a list.filter, and I say x mod 2 must be equal to 0, or in syntactic sugar, because you're just using the argument 1, I can say underscore mod 2 equals 0, just to speak to the concision of the Scala language, and that will just be the list containing just the argument 2. Now, with map, flat map, and filter, you can define what we call four comprehensions. Now, four comprehensions are those expressions that are not Scala loops, but they're rather chains of map and flat map. So I can say, let's call this chessboard as a for comprehension in num, let's call this in list 1, 2, 3, 1, 2, 3, and let's say a character in list with A, B, and C. I'm going to yield, and I'm going to return a string like number dash character, something like this. Now, this for comprehension is actually written in terms of flat map and map. This is not a loop. So the mindset of a for comprehension is very, very critical in working with collections properly. So it's quite important that you master it in order to work with collections in the right way, and also use all the skills that we've discussed so far with immutability and functions as values and so on and so forth, and not think in terms of iterations. So this is very, very important. Now, once you've learned collections and once you've learned functional transformations such as map, flat map, filter, head option, for comprehensions, and so on and so forth, the next skill that I find really important is to try to abstract away these for comprehensions and the map, flat map, filter from the idea of collections and the idea of iterations, such that you just filter out or you transform these collections into more abstract data structures, such as options and try. So I'm going to say option try. I can define an option as option int, and the first way that I recommend you treat these options is like mini collections with at most one element, and these are useful to eliminate the need for null checking, which can lead to some very defensive code, which is hard to read, hard to debug, hard to understand, and so on and so forth. So I can say option, let's say 42, and this option can then be processed regardless of whether it has a value or not. So I can say a transformed option as an option dot map, and I can say underscore plus 1 to transform this option into one where the value is incremented by 1, regardless of whether this option does have a value. If it does, then the value will be incremented by 1. If it doesn't, then the whole expression will return an empty option. So this will eliminate the need for null checks and defensive code, which is very powerful in real life and complex code. Another abstraction is try. Let's call this a try as try int. And a try, unlike an option which denotes a possibly absent value, a try denotes a possibly failed computation. So I can say try with an expression that might throw an exception, like throw new runtime exception. Now, this expression would normally crash your application, but because it's wrapped in a try, you can treat it as a potential container of a value of type int. So you can transform this data structure on as your code progresses, and regardless of whether this try has value or not, your logic still makes sense. So I can say a transformed try as a try map, and I can say underscore times 10. And if this try contains a value, then that value will be multiplied by 10. If the original try was failed, such as this case, the whole expression will keep that exception. Now, these options and try will also have map, flat map, for comprehensions, filter, and a bunch of other transformations such as or else. So the sooner you learn to work with these abstract data types in a functional way, the more productive you'll start to become as a Scala developer. Now, if you want to go a little bit further, you can go a layer deeper and learn about monads. This is another skill that I would recommend you at least read a bit on, because monads are this abstract data type that sounds quite scary, but all monads describe are chainable computations. And I talk about monads in 3 different ways, at least at the moment, on my blog and the YouTube channel, so you can pick the explanation that makes the most sense for you. The next skill that I find very, very important is futures and asynchronous multi-threaded computations. So futures denote the kind of computation that has not actually finished yet, or it may finish at some point in the future. That's why it's called a future. So I can say, let's call this a future as future. I'm going to import that as a type int, and the future can take the future apply method will take, so future.apply. And I can pass an entire code block, or you can simply say future with the curly braces, which is syntactic sugar for what I've just written. And here you can put some long running code, like thread sleep for 10 seconds, and then return the value 42. This will execute on a different thread. Now, this thing will need what we call an execution context to run. So I'm going to import Scala concurrent execution context implicits global in order to create a thread pool on top of which this future can run. Now, the concept of a future exists in other languages as well, for example, Java, but futures in Scala are much more flexible because they can be transformed with the same sort of functional programming primitives as other data structures, which make futures extremely easy to work with, at least in the early phases of becoming a Scala developer. So you can have, let's say, a transformed future as a future.map, and you can do whatever you want with the value inside, like multiply it with 100. And as the future completes, then this expression will complete another future with the value multiplied by 100. So you can transform these futures and so on and so forth as you see fit. You also have the same kind of transformers like map, flat map, filter, for comprehensions, or else, or rather recover. And we also have asynchronous callback based on complete, so that you can inspect the values returned by those futures. So learning what futures are and how they work will go a long way. And the final, very, very important skill specifically for Scala is contextual abstractions. And because I'm writing Scala 3 in this video, the equivalent contextual abstractions concept in Scala 2, the earlier version of Scala, was called implicits. And there are 3 contextual abstractions that you need to learn. First, you need to have the given and using combo. Given and using combo is a mechanism by which the compiler will automatically inject a value in a method. So I can say def, let's call this method with using clause. And you can pass an argument list like regular argument, such as an integer, and with a using clause, let's call this implicit arg as a string, and this will return an s quote. So this is a string where you can inject values inside. Let's say implicit arg dash regular arg. Now, the using clause makes the second argument list automatically injectable by the compiler. If you have a given value, for example, default language as a string, and this is Scala, of course, then you can call this method with using clause just with the first argument list, and the second argument list will be automatically injected by the compiler with whatever given value you have in the scope. So I can say, let's call this current version as a method with using clause with the number 3, and Scala is passed automatically. The second set of contextual abstractions is extension methods, which was another innovation of the Scala language that other languages caught up with. So we have the extension clause, so extension, for example, an n as an integer. So I can decorate existing types with new methods that would otherwise not compile. So for example, I can define a val or a method, let's say times s as a string, and this returns a string, and I'm just going to call whatever concatenation function I wrote before, so concatenate n. So concatenate n with n and s. Now with this extension method, that means that I can say Scala x3 as n, which is, let's say, 3 dot times with the string Scala. Normally, of course, the times method would not compile, but now because I've defined it as an extension method, it does. And this leads to some very, very powerful code. Just through the given using combo and extension methods coupled with generics, you can create some really powerful structures of code and design patterns, for example, type classes. So a bonus of given using combo and extension methods is the type class pattern, which I recommend that you read on because type classes are very widely used in functional programming libraries and in functional Scala. The third contextual abstractions that I recommend that you learn is implicit conversions. And this is a little bit more rarely used, but it's still quite useful. So for example, I'm going to define a given, let's call this string to person, and this is a conversion from string to person, the kind of case class that I wrote earlier, and I'm going to say with, so this is the kind of Scala structure that you need to write, and I'm going to define the apply method. So the apply method is important here. That takes a string and I'm going to return a person. Let's say person with a string and Scala as their default favorite language. Now with this implicit conversion in place and with the appropriate import, and that is because conversions are particularly dangerous, I'm going to import Scala language implicit conversions. I can write something along the lines of Daniel. I'm going to say Daniel version 2 because I already had a Daniel instance. I can say that Daniel version 2 is a person, and on the right-hand side, I can simply pass the string Daniel. Of course, this would be a type mismatch normally, but Scala automatically does a conversion. So conversion on Daniel. And through these contextual abstractions, you can get some very, very powerful Scala code, especially in the functional aspect of Scala, such as libraries like cats and Doobie and cats effect and Zio and that sort of stuff. Now, as a bonus, if you do have time, I recommend that you read on some other skills that are specifically targeting Scala, which is variance, which is extremely powerful in terms of the compiler capability to infer types. And variance is the core of one of the most powerful libraries in the ecosystem, namely Zio. We also have self-types. We also have type members, that is abstract type members, and type projections, and generally read about the Scala type system to get you familiar with how Scala works under the hood and the kind of features that you can employ in your real-life project. So these are my top 10 skills to become a good Scala developer. I hope you liked this video and enjoyed it and found it valuable. If you do, check me out at Twitter and LinkedIn at Rock the JVM and subscribe to my YouTube channel at Rock the JVM. And until next time, folks, I'm Daniel, signing off.